So now that I've shown you the basics of what an exponential graph looks like in Y, I want to show you two examples where we just kind of quickly graph them, or faster than I was in the last video. With exponential graphs, we're pretty much always going to graph them using a table. It's really probably the easiest way to do it. So with my first equation, I have two examples here. Also, I wrote a little note here. That asymptote that I described, the place where the graph levels off, will always be at y equals 0 for basic exponential graphs unless we move the graph up or down. So that's when we're going to start adding or subtracting numbers to shift it. That's going to happen in the next video though. So with both of these, neither of them has been translated, moved up, left, right, up, down. So there's going to be an asymptote at 0. Before I do anything, I'm going to go ahead and draw myself a dotted line at y equals 0, because that's going to help me guide where the tail of the graph goes, if it goes left or right or whatever it's going to do. So I'm going to make a few quick tables here. For my first equation, I have 2 times 3 to the x. I'm going to start plugging in numbers starting with 0. And you guys can just take your calculator and do 2 times 3 to the 0 power, and that will work. It'll get you the right y coordinate. If you do it by hand, though, you do not make these acidics. You cannot multiply 2 times 3 and just combine them, because you'd be breaking penalties. You're going to do the power part first, then you multiply by 2. So for example, I'll show just this first one by hand. 2 times 3 to the 0 power, 3 to the 0 is 1, times 2 gets you out a 2. So I'm going to go ahead and graph 0, 2. And I'm going to do a few points a little bit faster. If you plug in a 1, you'll get out a 6. If you plug in a 2, you will get out an 18. So we are already off the graph after just 2. So I'm going to do 1, 6, that's 2, 3, 4, 5, 6. And 2 is already off the grid, so I'm not even going to worry about that. I'm just going to do up arrow going this way. On my other side, I'm going to do at least one negative number. If I plug in -1, I will end up getting for this 2 times 3 to the -1, which should be 2/3, or 0.6 repeating, if you actually just type it in. So I'm going to have -1, 0.6 repeating, and it's going to tail off along the line right here. You need to use enough points in your table so that I can see that you understand what's happening with this. You get a couple. We know it's going to level off along this line, so I'm going to do a really flat part, really flat, hit my points right here, and it's going to get really, really steep. Okay, I just put an up arrow going like that. That's going to be our shape, arrows on both ends. For my first graph here, starting out, our horizontal asymptote, HA, is y equals 0. That's where it's always going to be unless we move the graph up or down. Our domain, it continues to be all real numbers. It's going to go left, it's going to go right. It's that way for all basic exponentials. Range, still y greater than 0. Last thing, there's no x-intercept, but the y-intercept on this one is 0, 2. I'm going to go ahead and graph my second equation on the same grid, so you guys can see them both together. And I'm going to switch colors for this. So I will do this one in green so we can tell the difference. If I go ahead, I'm just going to start by plugging in 0 and a few numbers after that. 0, if I type it in the calculator or do it by hand, I will get out a 4. I'm going to plot 0, 4 right there. If I plug in a 1, I'm going to type that in the calculator, do it by hand, whatever, I get 1, 2. If I plug in a 2, I'll get out a 1. So if you do that, 2, 1, 3 will get me out a 0.5 or a 1/2. And you can just keep plugging in numbers like this. It becomes clear though, the asymptote's still 0 because we didn't move up or down. But this time, it's going to be really steep on this side, and it's going to level off like you see right there, arrow going that way. On the other end, I should plug in at least one negative number. If I plug in -1, I will get out an 8. So I would go to -1, 8 and plot that. You can see it's getting really steep on this side. Running through my pieces real fast. Horizontal asymptote, y equals 0. Domain, all real numbers. Range, even though it's going this way, it's still y is greater than 0. And my y-intercept on this one is 0, 4. One last vocab word for this video. My two equations right here, one of them is going left to right, it's going upwards. It's increasing as we go along. One of them is going downwards as we go to the right. If it is going upwards, like my black graph right here, that is called exponential growth. Growth because the graph is growing from left to right. And my green graph right here is called exponential decay. When something is decaying, it's kind of dying or going away or whatever. Exponential decay because the graph is decreasing as we go along. If you look at your equations, you can actually tell just by looking at them. If you have a number bigger than 1 under your exponent here, it's going to go up as you go along. If you keep multiplying by a fraction, though, that makes your answer smaller. So if your answer is between 0 and 1 for B right there, that's when you know it would be exponential decay.